Finishing up this section on graphing other kinds of trig functions. In this example specifically, we're looking to graph a secant function. We are looking at y is equal to 2 times the secant of 2x. So in order to graph this, we need to graph its partner function, which we know the reciprocal partner function for secant is cos. So we are going to look to graph y is equal to 2 cosine of 2x, and then from there we'll go on to graph secant 2x. So let's identify some information here. We have a is equal to 2, b is equal to 2, c is equal to 0, and d is equal to 0. So no phase shift and no vertical shift. So A tells us that our amplitude is going to be 2, and now our period, which is for cosine 2 pi over b. Since our b is 2, we have 2 pi over 2. So our period for this function that we're looking to graph is going to be pi. And we know from what we've done in the past, we are going to take our period of pi and we're going to be dividing it by 4, and this is going to give us the increment that we're going to use to generate our 5 key values for graphing. So since there was no phase shift, our starting angle is going to be 0. I'll stick to the red, 0. And then to this 0, we're going to add our increment of pi over 4. So we have 0 plus pi over 4 is pi over 4. Add pi over 4 to pi over 4, and we get 2 pi over 4, which we know we can reduce. I'm not going to bother to reduce it, because I think in building the table it's easier just to keep adding. 1 pi over 4, 2 pi over 4, another pi over 4 would be 3 pi over 4, and then another pi over 4 would give us 4 pi over 4. So I think it's easier to see how the increments are being added to each of our subsequent angles without reducing. We will reduce though when we get to the graphing part. So there are our angles, and now we need to determine the cosine of each of these angles. So the cosine of 2x when x is 0 is going to be 1. And we know the way we've chosen these are representative. If we were to substitute these x values in this statement of cosine 2x, we would get 0, pi over 2, pi, 3 pi over 2, and 2 pi. No need to do that algebra because we know that from the angles that we've built here, that we've chosen. So we have 1, 0, -1, 0, and 1. But these are not the values we're going to be using because we do have a change up in amplitude of this 2. So all of these values are multiplied by 2, 2, 0, -2, 0, and 2. So here's our x's, here's our y's. Now we can get to graphing. And I kind of hoped we would have the values, the chart, and the graph at the same time on the screen, but that's not going to happen. So you'll have to look at your papers for the values. So here are my x and y axes. You can see, being we have an amplitude of 2, 1, 2 on the y-axis, -1, -2 on the y-axis, and then our x-axes are in increments of pi over 4. So we have pi over 4, 2 pi over 4. Here I have reduced it. It's pi over 2. 3 pi over 4, 4 pi over 4, which reduces to pi over 4. And then I have continued on the negative side, negative pi over 4, -2 pi over 4, and -3 pi over 4. I forgot to mention why. We'll look at that in a minute. But let's graph the cosine function that we have so far. So when x is at 0, our function value here is 2. At pi over 4, we are at 0. At pi over 2, we are down here at -2. At 3 pi over 4, we are at 0. And then at 4 pi over 4, or just pi, we're back up here at 2. So connecting the dots, remember these curves are not pointy here. These are not absolute value looking. I've seen on some of the homework they look more like absolute value. They are what we call smooth here. They are rounded edge. So here is the one cycle that we've sketched based on our information. However, going back to the initial problem, we're asked to graph this between negative 3 pi over 4 and 3 pi over 4. That's the reason why when I made my graph here, I included these negative values as well. So here is our 3 pi over 4. We've included a little bit more information. That's not a bad thing, but we do have to continue our graph on this side. And now we've spoken about symmetry before, but symmetry can be extremely helpful in graphing because this is an even function with symmetry with this y-axis. So we know what's on this side is going to be a reflection of what's on this side of the axis. So at pi over 4, we're at 0. So negative pi over 4, we're also going to be at 0. At pi over 2, we're at negative 2. So at negative pi over 2, we are going to be at negative 2. And then at 3 pi over 4, 0. So at negative 3 pi over 4, we're at 0. And I'll sketch this in just because we know it's going to continue. And there we can see the symmetry. I mean, it could be a little better if I was a better artist, but I'm not. This is why I teach math. So we can see the symmetry here. However, this is cosine here. This is our function 2 cosine 2x. That's not what our mission here is. We want the secant. So in order to graph our secant function, we need to put in vertical asymptotes. Every time we have a 0 in our cos, so at 3 pi over 4 here, we're going to have a vertical asymptote. At pi over 4, we have a 0 for cos, and that's going to give, whoops, that's really pretty bad. Okay, we're going to go with it though. Another vertical asymptote at negative 4 pi over 4, negative vertical asymptote, and then negative 3 pi over 4, another vertical asymptote. So we know our secant is going to be going on in between these asymptotes. So let me switch to green here. To finish putting in our secant function, wherever we have a minimum for cos, that is going to become a maximum for our secant function. So here and then here. And again, the symmetry, we can see the symmetry and have used the symmetry to graph over here. Then, at our maximum here, this becomes a minimum for our secant function. So we have something like this. I haven't sketched it yet, but I could. We know that we're going to have another repeat over here. I mean, this is more than we were asked to do, but that's okay. And over here, we would have something similar going on. So these greens, this is the function 2 secant 2x here and then there.